Hello everyone and welcome to my channel. So if you have seen my first video on coordination compounds, so this is the second in the series, and here we will talk about the general terms that are involved in the coordination chemistry. In this video we will learn about the central metal atom, the ligands, the coordination number and the coordination sphere. So let's get started.
Hello friends. So in the last slide we discussed the basic concepts regarding what are coordination compounds and how we can distinguish them from double salts. Now in this section what we will discuss is a few terms which are very commonly used when we study the coordination compounds. Okay, now from the last slide, as you had seen that I have written a few coordination complexes, as you can see. So these can dissociate like this. So the copper, as I have written here, the first complex as the copper complex, second one as the silver and potassium, and the third one as the platinum. Okay, so the first one dissociates like this. As you can see, we have this complex cation, right? Now here we have, in the second example, we have the complex anion. In the third example, the platinum one. So as you can see, this is a kind of, you can say, a neutral complex. Okay, so this is a neutral complex. So no charges are mentioned here, so we will categorize them as a neutral complex. In coordination compounds, we can observe the neutral complexes without charge, and then we can observe the ions also, which are complex cations or complex anions, like this. So these many different forms you can see in the coordination compounds. Okay, now there are few terms which are very important when we will deal with these coordination compounds. So the first term which is important is the central metal atom. So the central metal atom or the ion, central metal atom or central metal ion, whatever is the case. Ions in case of the complex ions and atoms in case of the neutral atoms. Okay. So which one is the central metal atom? So as you can see, central metal atom, that has to be a metal atom, okay, which is central to the system. Okay, now in the first example, as you can see, there is just one metal, that is copper, and this one is the central metal atom, right? And then in the second example, you have potassium and silver, but the complex part, the part which is designated as the complex part, which has the species known as the ligands attached to the metal atom, that part gives us the central metal atom. So potassium is not the central metal atom in the second example, but silver is the central metal atom, right, which is attached to the cyanide ions. Okay, now in the third example, just one metal is there, that is platinum, and that is why this platinum is the central metal atom. This is how you will recognize that which one is our central metal atom. So coordination complex has one central metal atom, and then the second part is the ligand. Okay, so second is the ligand. So what are ligands? Ligands are the species that are coordinated with the central metal atom. That means that species which is directly connected or coordinated with the central metal atom is known as the ligand. Now how to identify the ligand in the coordination complex? Okay, now in the first example, as you can see, copper is directly attached with 4 ammonia molecules. So here ammonia is the ligand. Okay, so ammonia is the ligand, right? Then in the second example, as the central metal atom is silver, and silver is coordinated with 2 cyanide ions. Okay, so this Cn is the ligand here. Okay, similarly, so Cn is the ligand in the second example. Similarly, what is there in the third example? So third example, you can see that platinum is attached to the 2 ammonia molecules and 4 chlorine atoms. Okay, so here the chlorine atoms as well as the ammonia, both are the ligands, right? So these both are ligands because they are directly attached to the central metal atom, right? Okay, so as we had discussed in the previous introductory slide, that what is the characteristic of a ligand? Ligand is electron rich, right? And it acts as the donor. Okay, donor means it will donate its electrons to the central metal atom, which is having vacant orbitals to accept these electrons, right? Okay, so that means the central metal atom is the electron deficient part or the acceptor, right? And that is why, since the ligands have this tendency to donate their electrons, so they can be a negatively charged species or neutral molecules as well, which contain lone pair of electrons, right? So the neutral ligand, the most common example of a neutral ligand is ammonia, right? Ammonia contains no charge, it is neutral, but since it contains the lone pair on the nitrogen atoms, which can be easily donated to the central metal atom, that is why ammonia can act as a ligand which is neutral. Otherwise, we have seen in the second example, Cn minus is the ligand because it has negative charge and it can easily donate its electrons, right? So it can be neutral and it can be negatively charged as well, these ligands. Okay, now the next part that we are going to discuss is the coordination number. So we calculate the coordination number of the central metal atom, right? Okay, so now what is a coordination number? So the coordination number of a central metal atom or ion can be defined as the number of ligands, right? The number of ligands which is attached directly to the central metal atom or ion. So what does this mean? That we have to calculate when we are talking about the coordination number, then what we have to check out? We have to check out just the number of ligands which is attached to the central metal atom, right? So if we look into the first example, you can see CuNH3 whole 4 SO4 in the first example. So the ligand which is directly attached to the central metal, that is copper, is ammonia. So how many ammonia molecules are attached? So 4 ammonia molecules. That means the coordination number for copper in this complex is 4. So the coordination number of copper is 4 because 4 number of ligands, 4 ammonia molecules. Similarly, in the second example, we can see that 2 cyanide ions are attached with the silver central metal. Okay, so that means the coordination of silver in case of the second example should be 2. So coordination of silver in second example is 2, right? Because 2 cyanide ions are attached to the central atom. Okay, now what about the third part, the third example, platinum Cl4 NH3 whole twice. So since we know, we have seen that what are the ligands in this case. So ligands are Cl4 and NH3 whole twice. That means there are 4 chlorine atoms and 2 ammonia molecules. That means we have 4 plus 2, that is equal to 6 ligands for platinum atom. So that means the coordination number for platinum should be 6, right? So this is how we calculate the coordination number of the central metal atom. Okay, next we will get to know what is a coordination sphere. Okay, what's a coordination sphere? So whenever you will come across the coordination compounds, you will encounter the terms as coordination sphere. So what is a coordination sphere? A coordination sphere is that part which contains a central atom and the ligands which are directly attached to it, right? So this part forms the coordination sphere. That means the part which is within brackets is the coordination sphere, or precisely the first coordination sphere, right? And the rest of the part, apart from the central atom and the ligands which is within brackets, the rest of the part of the complex is known as the second coordination sphere. So if you look at these examples, the first, second and third examples, what we have within the brackets, in the first example we have this copper NH3 whole 4. So this part is the first coordination sphere, while SO4, right? Okay, this the rest of the part which is outside the bracket is the second coordination sphere, right? Similarly, the this part in the second example, AgCN whole twice, which is within the brackets, is the first coordination sphere, and the rest of the part, that is the potassium, is the second coordination sphere. Okay, and in this one, in the last example, what we have only one species which is within the brackets, so we have only one coordination sphere, which is this entire thing which is within the brackets. Okay, so this is how we identify the two coordination spheres, the first and the second. The first one is the central metal atom and the ligand which is within the brackets, that is the first coordination sphere, and rest of the part of the complex which is outside the square brackets, that is the second coordination sphere. Okay, now let's just have a quick recap of all the terms that we had studied related to the coordination complex. So first of all, we identified what is called the central metal atom. So I have written an example here, K4FeCN6. So what is the central metal atom here? The central metal atom here is iron. So iron is the central metal atom. Next is the how to identify the ligands. Okay, the species which is directly attached to the central metal atom is the ligand. Okay, so what is the ligand here? The cyanide ions are the ligand. The 6 cyanide ions are directly attached to the central metal atom, and these are the ligands. So this is the second term that we learned in the coordination complex. Okay, then we focused on what is known as the coordination number of the central metal atom. Okay, so what was the coordination number? So coordination number was the number of ligands, right? Ligands. So number of ligands which is attached to the central metal atom. Okay, so the number of ligands that are attached to the central metal atom is the coordination number. So how many cyanide ions are attached to iron? So you can see 6, Cn whole 6, so 6. So coordination number of iron should be 6 here. Okay, then we learnt about the coordination sphere, right? The species which is within the brackets, right, that is known as the first coordination sphere. So this one is the first coordination sphere. Okay, so FeCN whole 6, the species which is within brackets is the first coordination sphere, and then the rest of the part which is outside the square brackets is the second coordination spheres. Okay, so now we have all the terms, the first coordination sphere, the second coordination sphere, then the central metal atom, and the ligand, and the coordination number. So all these terms we had learnt in the section where we discussed the general terms related to a coordination complex. So hope this is clear, all the terms, and hope it helps. Thank you.
So I hope you have understood the few general terms which are involved in the coordination compounds. In the upcoming videos, we will learn about ligands in detail. Please comment on anything that you have not understood or you have some doubts. And please do not forget to like, share and subscribe if my videos are helpful to you. See you soon in my next video. Until then, thank you so much for watching.